our roof system, it's an intensive flat.
Speak up a little.
Flat roof. And we envisioned that this is downtown Seattle. This is an apartment, a co-op apartment building. So this would be a shared space. The food beds, everyone would have to chip in and put in hours to maintain them. We have an herb flower bed and a reflection pool here. This would be where this decking, interlocking decking, and seating, and then here, this would this be
We've got
covered?
a cover over it, and so on the back of that, we've also got a solar and maintenance shed and things like that. But on this side, we were going to collect the water. We just haven't drawn that. Collect the water here and then filter it through here. We'll have a sedges and other water plants that are going to filter that. And we've got bamboo. We have a green wall screening here. Stone pines here. We have the slim tank storage for good visual, and also because there's a building here. So that's going to add a lot of colors. On the side, we're going to have those small canister wind turbines to power some of the cooking items that are going to be used, like the grills and things like that. Anybody else?
Yeah, this side wall on the north side is going to have a low wall, but then it will have vegetation, this Alexander's plant and blueberries, so that you're getting some breakdown in the wind and improving the ability of your food beds to grow anything. But also for visual screening, to create some feeling of where the edge is. We tried to indicate that there is an edge to this roof, that it's not a field somewhere. And of course, it'd have to have the appropriate safety features so that nobody would ever fall off.
So the reflection pool is in a frame then, right?
Right.
And it's very shallow.
Okay.
It's not
It's
a lot
really
of water.
cool. Very good.
And this was sand, so that you could actually put your feet in it.
Okay.
Maybe a little Zen garden.
Uh-huh.
And the bamboo would add a nice sound with the wind going through it, as well as it could be used for building material for the raised beds. And this would all be just the typical like flat roof materials so that it's ADA accessible and it would be low maintenance.
Okay. Cool.
Are there other materials that are ADA acceptable besides just?
On roof, pavers. You can
Pavers,
always put
okay.
pavers up.
Okay.
Yeah. Any decking material, really.
Okay.
Yeah. In fact, it's probably better because regular roof material has a tendency to heat up and to sort of be slippery sometimes. But pavers, you can control traction.
We did this with a deck at the house that we greened in Everett, and it's got waterproof membrane,
Yes.
but then it has Trex pallets, so that you can pick those pallets up and keep it clean, but you don't have the heat accumulation on your feet.
Yeah.
It circulates better.
If this was a stormwater management system, would the reflection pool do what?
Collect water.
And filtration.
Yes, but as far as stormwater credits, what would it do? It would actually take away from your credits because this is filled with water and it cannot store more. Because it's a reflection pool. It's not a system that fills up with rain and then goes away, but it's there, continuous. So you can't add more water to it. Therefore, this area would be deducted from your surface.
But if we
Okay.
have other storage containers on site, could we get those points back?
We'd have to
Yeah, you can do, exactly.
pump it indoors.
Yeah, you would have to do something else, like more cisterns or something. Just, no, it's awesome. I love it. And it actually, for habitat value, it's huge, really important. But because we're not only losing canopy, we're also losing a lot of water surfaces in our cities. Just know that it's not counting as a stormwater credit. So we talked about this a little bit in the beginning, that things that happen on a roof can be very important in terms of code and permitting, especially when it comes to stormwater codes. And I also mentioned that our directives are driven by certain things like water quality and salmon. If something hits us in the pocketbook, we pay attention. And that's going for our society. The biggest thing that hits US in the pocketbook is water quality. And so our most comprehensive code systems that are there to ensure environmental protection for anything is through water-related codes. We don't have air quality control codes the way we have water quality control. We don't even speak about soil quality control. It's all water quality. And so that's why when environmentalist groups are trying to get something through, they come in from, as many times as they can, from a water angle. Because our water protecting codes actually are really comprehensive, and it's in the context of global code systems. US has a very good water-focused code system. And that's something to keep in mind, because when you are trying to push through some new ideas and new things, it gives you an angle if you can talk to stormwater quality, water quality, salmon and water habitat quality. It's an important tool as you're talking to permitting departments. Because even though a vegetable garden like this, with all these features, not going to give you stormwater credits, it still gives you water quality, improved water quality. And it gives you an important habitat that then relates back to the nearest water body. Because if you have happy birds who can actually have a drink, then they have a chance to survive their city visit and can go back to that stream that's, a few blocks down the street. So you can talk to those codes as you are getting permits for this roof system. By putting the cisterns up, you are protecting the watershed. By using that for irrigation, you are reducing the stresses on the potable city water and that system. So you can use these terms very effectively to get a permit, because otherwise, if you just walked into the city hall with this, everybody would be in love with it and would deny you the permit. Yeah, this is so good. I would love to have one if we had codes that allowed it, but we don't, so sorry. Because, that's just it. But if it's water quality, now you're talking.
And Zsofia, a lot of these codes have come about because of American Water Works Association.
Yes.
My husband's a civil engineer, and they all are very aware of what it takes to have clean water for drinking. So
Yes.
there's been decades of improvement in all those ideas.
Yes, and drinking water is a really big deal. So we had, in 1948, the Water Pollution Control Act that started, that later on, I'm not going to go through this, I will have it as a PowerPoint for you guys, and if you love code, you can go through it, it's great. That actually, the Water Pollution Control Act that drove everything up to the point of our National Pollution Discharge Elimination System program coming along. With these codes back then, we had no enforcement, so there was this ideal that would be so nice if you did do, but there was no enforcement, so industry still went ahead and did some other stuff. And so we ended up with all those really big problems by late 60s and in the early 70s that drove the US into having then the big protests and upheavals that resulted in the EPA, the Environmental Protection Agency that was created. The one good thing that actually Nixon really did leave us is the EPA. And with the EPA, here we go actually, it started a new process, because the Environmental Protection Agency, as it came into being, it was a very small group, seriously, a handful of people, and they had regional offices, which was a desk and a chair in a very small place in not the highest value properties in whatever region it was, and a typewriter, and they were trying to assess situations for that region and create some goals and objectives, and then formulate some code system. So as they were working through this, and I want to remind you that when this is happening in the US in the early 70s, nobody else in the world is even talking about this stuff. And so we can complain all about how we are doing this and we are doing that, but we have something that's very unique. And that is this whole water policy that US has. So it started out originally EPA with the 5 programs of looking at and regulating air quality, water quality, and looking at the effects of pesticides, because after the Silent Spring came out, it was pretty obvious that there are some effects of that, and the effects of radiation, and then to deal with solid waste. So if you actually can think about this, but water quality drives solid waste management, because solid waste does leak into our waters. And as far as polluting agent, solid waste facilities are a really big problem. And they also seep into the aquifers, whatever you put out there. Radiation. We have Hanford in the state. You all hear about the challenges with that, the problems. So pesticides. And then the air quality sort of like also as a habitat and how it interacts with water. And we had a few years when Congress thought that they can vote on these things about what's pollution and whatnot, but we're moving away from that now, hopefully. So these were the 5 original big areas that they were looking at. And then they had 3 groups, 3 arms. They were doing a lot of research because nobody had data on pollution. I mean, yeah, we knew that if you drink a bottle of bleach, you're going to die and suffer horrible death. But why is it a toxin? How does it quantify in water? How do you control that? What's acceptable and what's not? We had no data on that. So they were doing all the research, and then they tried to do enforcement with very limited budgets, because guess what? EPA was never on the highest receiving end of money. So if they were a military force, we would have a lot more budget, but they weren't, so they didn't have a lot of money. So whatever they could do with enforcing, and mostly they decided over the years that education is the best enforcement, because then they can count on the very group of people who they are working with, the neighborhood. And then they had the management, and that was sort of like whatever policy was created, you had to sort of follow through. If you request that people give you permit applications, somebody has to be able to take that permit application, evaluate it, provide you with a permit, follow up. That's all management. And they had that program running. So when I teach codes, sometimes it gets a little bit boring, so I have some funny stuff in there sometimes. But that's where that comes from, and you wonder why I have cartoons in the presentation. So then in '72, the Federal Water Pollution Act actually started today's NPDES systems and regulations. And what was the goal of that is that by the middle of the 80s, we have all pollution discharge, meaning any industry or home that has a pipe that directly ends in a natural water body, all of those will be mapped and stopped if that pollution went into a navigable water. Meaning that the little stream behind my house didn't count, but the Snohomish River or the Stillaquamish River did. And that was a big deal because we had a very big pollution problem in our water. So we couldn't reach this goal. I mean, think back, and we didn't reach this goal. There was so much work to be done and so few people doing it that by the middle of the 80s, EPA didn't even have all the definitions of what was the pollution discharge, what counted as such. A few things were obvious, many things were not. So as it went forward, they were doing all the research still, and then they started deciding how are they going to be enforcing this, and they went back to the wastewater. That's what takes us back to the combined sewer overflow challenge, because they saw that when a sewer system overflows, there will be obvious pollution. That's really a no-brainer. And so they started asking that wastewater facilities will be using the best and most effective technology that they can get feasibly when it comes to economy. That's a big trick, a big challenge, a big loophole. Because if a wastewater facility proved that they don't have the funds to apply the best technology, then they were off the hook. And so we had this regulation, but it really was quite ineffective. And then it started that wastewater became the string, sort of, that helped EPA with reinforcing compliance. And this is why, for example, the NPDES program permits are tied to the operation of wastewater facilities. If a jurisdiction loses their NPDES permit, the next day they have to shut down their sewer system. And it is because none of us wants to get the notice that you no longer can flush your toilets. We will be very unhappy very quickly. And so to keep the pressure on jurisdictions with compliance, this is a very smart way of actually forcing things to happen. And then the navigable waters is another problem. But this is where they decided at that time that, believe it or not, discharging pollutants into navigable waters became not a right. Because it was a right until then. Because we still actually have Nestle's CEO stating that to have potable drinking water that doesn't kill you is not a human right. It's still an arguable point. Nestle declared it. You can hear him say it. You go online, you can hear him say it. It's not a right to have clean drinking water. But if you pay for it, you're welcome. So this is the really quick and dirty background story of the NPDES that ultimately will drive your permit applications when you ask for a roof, for example, that you want to put on a planted roof. And it's technology-based and water quality-based. So the goal is the water quality that's increased, and it's achieved through a technology. This is where it gets really fascinating to me, because it's very creative. And they started issuing the permits, and so we were in phase 1. And it's a long story. But phase 1 practically required that all states, all counties, all cities, and all constructions or site disturbing activities of 5 acres or more have an NPDES permit. And this permit is for 5 years. So as the organizations got their first permit, 5 years later it expired and they had to reapply. And in order to get that new permit, they had to prove that they complied with the minimum requirements that were given, plus they actually fulfilled all of those requests that EPA told them to improve on during the 5 years. And so if they did, they got a new permit. And then now, with 2012, we actually got everybody up to standard on phase 1, and we kicked in with the phase 2. And the change on that is that phase 2 is 1 acre disturbing activity or more. So we went from 5 to 1 now. So if you're actually doing a construction and your site is 1 acre or 1 acre or larger, you have to apply for and receive a permit for that project. And that has to do with the water quality, the NPDES. And then part of phase 2 also requires education. It says it in there. This is why over the course of these past 2 years, you've seen so many public educational activities focusing on water quality, for example, in our area. Because now cities and counties and states are required to provide this education around water quality and pollution and sustainability. It's part of the whole program so that they can actually cut back on enforcement, and it will become a second nature of people to do things better. And it's working. We know education works. It's a positive reinforcement. And it's building better communities too. We now have a code system in the entire country that is unified. Chicago is the only one that has its own code, but everybody else now, as of 2008, actually is on one platform. So it's pretty recent if you think about it. But imagine companies who worked across the board and had to have all of these different systems. But we now require that sewer and runoff controls are separate. They no longer function together. And so we have to do the non-point pollution discharge elimination, which is more like the roofs and the parking lots. Because in an industrial setting, you have one pipe coming out from that facility, and you know where that pipe ends, and you know what comes out of it. You can control that fairly easy. But when you look at all the roof and parking lot surfaces, it varies what's on it. The toxins and the pollution is never the same. You can't even exactly point to where that comes from and where that goes. There are a gazillion different pipes. It's much more difficult to control. Actually, if you have these type of roofs, you're helping with that. You're helping with the non-point source pollution control. Food gardens do that. You don't have runoff from an urban farm, because if it's managed right, the soil is happy and it's absorbing the water. It soaks it in, and then it filters it too if it comes off. So when you want to present this idea, you are going to have every jurisdiction ask you for different information. Even though we are on the overall, since 2008, big code book that is actually the International Building Code, and it is called International because the US had one of the area, the midsection of the country, called their code the National Code. And so when they did the combination, they created the Unified International Building Code, and that's what runs the US code. It's a US code system. But these are just like, the nonsense of code history actually is very fascinating to me. I think that's really something that I really enjoy reading about. But you have to go into your jurisdiction and find out the specific details on how they are making sure that they are complying with things like the NPDES, with the Unified International Building Code, which is actually a performance standard. So it doesn't tell any city that you can only have 8-foot tall walls that are 2 feet thick. It gives you a standard that your buildings have to stay up in a 9.4 earthquake. You know, you can have a certain percentage of loss of life and damage. That's it. That's a performance standard. How you get there is your deal. It's up to the city. It's up to the state. They give you the results of what you have to have. They're not going to give you the means. And it enables people to innovate. It enables people to put in new ideas and explore. if you had a recipe book on how to build a house and that's the only way you can build a house, that would be horrible. So you go into the city, and there will be regulations, more than likely, on what the structure has to do, because you're putting roof on a building, and how to prove that. They will tell you, more than likely, to talk to a structural engineer, but they may also require some other professionals who have to come in and help you with consultations. Then they may have standards on irrigation of that roof. In some parts of the country where we have really high fire hazards, or fire danger, green roofs can become a hazard. If you dry it out and it has grassy material on it, it will catch on fire no time. So they sometimes require to have some irrigation system. They will have requirements on how to have a path or tie out or safety feature on your roof, so that some jurisdictions will have a requirement regarding maintenance. And then there will be a height regulation, more than likely, because when you plant things on a roof, your roof line is increased, and if you happen to be in the view of the next building, there may be regulation that controls what you can put on your roof. Maybe an apple tree is too tall, but you can put on a blueberry bush, or it has to be a sedum or a clover, because that's it. You have to look into that, what you can do as far as height. They will more than likely ask for the engineering plans and then a planting plan in order to see what you're doing. They may have some specifications about soil mixes too. It's starting to be that way. Because, for example, in the city of Seattle, they had some roof failures due to bad soil, and it's really hard on the whole neighborhood when you have to stop everything again, and the crane has to come in, and they have to take it off and put it back on. And so now they actually have standards, that these are the soil standards that you have to utilize when you're putting in the roof. And then with your cistern system, if you put in a cistern, they will want to know what your plan is with that water. You cannot sell it. You can use it in your landscaping. In some places, like Lopez Island, you are encouraged to use it as your drinking water also, so that they will, because they don't have good well systems there. Some places they will say no to that. And they want to know your plan and how fast you are going to return it back into the environment. Because they, at the same time, while you're collecting all this rainwater, they want to make sure that your soil does get recharged, the area around you. I mean, ultimately, they want this water in the aquifer. They want it to go down into the ground. And then for the insulation part, it will be a very important piece even on the walls. Heights of things, for walls and fences, for example. The city may not have a regulation, or they may. They may say that it can't be taller than 6 foot, or it has to be designed by an engineer if it's taller than 6 feet or 8 feet. Those are all things that you can follow up then and maybe do your fence a little shorter. But homeowners associations is another one that you really want to look into, and it's often forgotten. Cities, counties, state are now in the state of Washington actually are pretty good at packaging their permitting. So if you go into, for example, the city, they will give you a permit application that will pretty much cover what the state requires from you too. And the city will take care of that. You don't have to go to the state on a separate note in most cases. There are a couple of other bigger projects where you do. But homeowners associations are not covered by your city or your jurisdiction. That's something you have to figure out. And what's really interesting is that if that association actually is sort of like not an active association, some people may buy into that neighborhood and don't even know that there is an association until someone comes and knocks on their door that what you just did is against the HOA regulation. So really find out. And if you don't like those regulations, try to work within the system and change it. And that's actually another thing that in the US is so important, because we can change policy and regulation. We may not really influence who's in the White House, but we actually have a say in what happens here around us in town. Because, you know, now with corporations being able to pay for political parties, we can't compete with that. But you can really influence what's going on in your immediate county and neighborhood. So get involved, and if you want to see roofs like this, which, you know, I really encourage, this is just really awesome, and everything that we had talked about, you want to have that library letter on the side of the house, go and make sure that we have policy that allows that. Get it into the planning, the long-range planning, the 10, 15, 20-year planning when those are happening. And that's a lot of times what I see is us people here who love plants, we want to ignore the policy side of things, but then that policy drives what we can do with our plants. So we should be more active and really take it seriously.